Hello again, everybody. We are going to do problems 10-37 to 10-39. We are skipping 40 just for time purposes in this video. Homework is 10-43 to 10-49. Okay, so starting off at 37, it says consider the series 1 plus 2 plus 3 plus 4 plus dot 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 plus n. Okay, so 10. 1 plus 2 plus 3 plus 4 plus dot 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 plus n. What is the sum of the first 3 terms and the first 10 terms? Okay, so for the first 3 terms, I would not go all fancy with the formula. I would just add the first 3 terms together and I would get 6. However, about 10 terms is where I get lazy, and I'm going to do the formula. So sum equals n over 2, so 10 terms means 10 numbers. First number is 1, and then what will the 10th number be? It will be 10. I can tell just because they're going up by ones, and this is 55. E. What is the sum of the first n terms? That is, what is 1 plus 2 plus 3 plus 4 plus dot 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 plus n? Justify your answer. Okay, so some of these series have interesting formulas that you can use to find a number for the sum way down the list without having to calculate the last number, which is great. So in this case, we have 1 plus 2 plus 3 plus 4 plus dot 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 plus n. Okay, so the sum equals, and it says the first n terms, so that means that we have n over 2. We don't know what n is, we're just finding a formula for it. The first number is 1 and the last number is n. Okay, and so we are going to leave this like that. That is our formula. So I could plug in any number here and find the sum. For example, let's try 3 just to check this. So 1 plus 3 is 4. 4 times 3 is 12, divided by 2 is 6, so it gives me that answer. Okay, now, C. Legend has it that long ago, when famous mathematician Carl Gauss, hey, we already worked on that, was a young student, his teacher tried to keep the class busy by giving them I already told you all this. Okay, what is the sum of the first 100 counting numbers? Okay, so sum equals the first 100 numbers. The first number is 1 and the last number is 100, and I don't know what that is. 101 times 100 divided by 2 is 5,050. And how did Gauss do this? If you remember, it's because he wrote it out twice and added up the columns to all be 101. There were 100 columns, but he had to divide by 2 because he had written it twice. Okay, 1038. Okay, in problem 37, you wrote a general expression that gives the sum for the first n counting numbers, but what about other types of numbers? Okay, so our goal in 38 is to do this, take this formula and write it for different series. So for A, they want us to look at the series of even numbers, 2 plus 4 plus 6 plus 8 plus dot 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 plus 2n. Okay, so that means it's 2n because the number of terms is multiplied by 2. So this is, let me get a different color here, n is 1, 2, 3, 4, and then so you multiply by 2 to get each one of the even numbers. So this is just what spot they're in. Spot 1, spot 2, spot 3, spot 4. Spot n is the number 2n. Okay, so we're going to come up with the formula for this. And that would be sum equals n over 2. There's still n numbers, so notice I have that in red. First number is 2. Last number is 2n. Okay, and we can do a little bit of fancy algebra here if we want to. So we have n over 2 times 2 plus n over 2 times 2n, just doing the distributive property, n plus n squared. Cancel, 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 cancel. Yep. Okay. B. Next one, it wants us to look at the odd numbers. 1 plus 3 plus 5 plus 7 plus dot 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 plus 2n minus 1. This is the formula for an odd number. You multiply it by 2 and then subtract 1 to get the odd number. Okay. Sum for this, n over 2. Notice there's still n numbers here. First number is 1. Last number is 2n minus 1. Okay, let's do a little bit of fancy algebra here. So I have n over 2. The 1 and the minus 1 cancel. I have 2n, and that gives me n squared. Use your expressions from part A and B to calculate the sum of the first 100 even numbers and the sum of the first 100 odd numbers. Okay, so 100 even numbers. This is the even sequence, so that's going to be sum equals 100 plus 100 squared. I am plugging 100 in for n here and here, and this one is the even one. So that would be 100 plus 100 squared is 10,100. 100 odd numbers, sum equals 100 squared. Here is the odd formula, n squared. I just plug in 100 for n. And that is 10,000. Okay. 39, last problem. Terrell notices that if he adds the first terms, second terms, third terms of the two arithmetic series right, he gets a brand new series. Describe Terrell's new series. Is it arithmetic? How many terms does it have? Okay. So let's write this down. We have 1 plus 2 plus 3 plus 4 plus dot 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 plus n. Okay, so that's known as the counting numbers. That's Gauss's numbers there. And then we have the evens, 2 plus 4 plus 6 plus 8 plus dot 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 plus 2n. This gives us the evens, and we are told to add those together. So 3 plus 6 plus 9 plus 12 plus dot 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 plus 3n. Okay, what do you notice about these? Well, they're all multiples of 3. And how many terms are there? There are 3n. No. There are n terms. Oh no. Oh no. Where's my whiteout? there are still n terms. Okay. Alright. Use your expressions from problem 37 and 38 for the sums of the original series to write an expression for the sum of the new series. Okay. Alright, so if I go back up here to the counting numbers, I've got the formula for the counting numbers is here, so n over 2 times 1 plus n, and then that's the top row, and then the bottom row, which I'm adding, is this guy, this guy, which I'm going to add like this, it'll make it easier, n over 2 plus 2n, before I did any of my fancy algebra here. Okay, so now how to do fancy algebra for this. I am going to factor out n over 2, 1 plus n plus 2 plus 2n, which equals n over 2, 3 plus 3n. Okay. Is there another strategy you can use to write the expression for the sum of the series? Yes, we can use the Gauss formula. Okay, so let's do that. So sum equals, okay, so we're looking at this one right here. Let me make sure I'm showing, yep, okay. So we're looking at this one right here. There's still n terms in it over 2. The first term is 3, and the last term is 3n, which matches exactly from what we did in problems 37 and 38. Okay, we are skipping number 40, as I mentioned, just for time. I think we've gotten in what we need to, and hope you guys are doing great. Thanks.